All right, welcome back. We are going to finish up section 1.5 today, and it's called Solving Combined Inequalities. So we're kind of doing the same thing we did on part 2, at least towards the end with those two examples, but we're going to do a combination of inequalities. Let me tell you what I'm talking about. We're going to start right off with an example. No pre-teaching or anything like that. So it says to solve, and here it is. It's an inequality. So you've never seen anything like this when it comes to equalities with equal signs, but you can see this stuff with inequalities. Basically, it means we want to find the value for x that if I multiply by 3, subtract a 2, it's going to be in between. It's going to be a number that's between -5 and 1. What is that number? All right, that's what we're trying to do. You could do this a couple ways. All right, here's one way that you could do it. I probably would not end up doing it this way. Okay, I'm just showing you just to see how it works. When we do the next example, we're only doing 2 examples on this lesson. When you do the next example, I'm just going to start off doing it the second way. So we're going to do this 2 ways. Here's the first way I'm going to do this. What I'm going to do is I'm going to separate them into 2 different inequalities. All right. So what I'm going to do is I'm going to take, let me try this again. I'm going to take this part right here and write it down. And then I'm going to take this part right here and I'm going to write it down. And I'm going to solve 2 separate inequalities and then come up with basically one answer. All right, let me show you what I'm talking about. Let's do this part first. So I'm going to write -5 is less than 3x minus 2. And I'm just going to stop right there, and eventually we're going to solve this. Let's do the second part of it. So let's write 3x minus 2 is less than 1. So I'm going to solve 2 of these problems separately and then put them together. So let's go ahead and do this. Let's get x by itself. So I'm going to add a 2 to both sides. All right, we got a -3 less than. We added numbers so we don't have to change the inequality. That cancels out. This is 0, and then bring down to 3x. Get x by itself, so we divide by 3. Again, we divided, but we divided by a positive number, so I'm not changing that inequality. So that gives me a -1. This is less than, and this just comes out to be an x. All right, so we are going to stop right there and then do the other one. So let's do this. We'll do it pretty quick. Add a 2 to both sides. 3x. Again, we added, so we don't change the inequality. That's a 3. Divide by 3. We're dividing by a positive, so we don't change the inequality. All right, so now we got these 2 answers, okay? But what we're going to do is we're going to combine the answers into basically one thing. So think about what's going on here. Tell you what, it might be a little bit easier if we actually graph the thing. So let's take a look at our numbers. I've got a -1 and a +1. So what is it? Where is x? X is greater than. Remember, if I'm reading it from right to left, so I could write this if I wanted to. Instead of reading it from right to left, we could go left to right. So instead of, if we read it from right to left, it would be x is greater than -1, or I could write it like this. This and this are the same thing, really. So how would I graph x is greater than -1? Well, it's open, and then it's everything to the right. Now, technically, it would keep on going, except you have a second part of this. X is also less than 1. Again, it's a parentheses. So x is less than 1. So x is a number that's larger, greater than -1, and also, put an and right there, okay? And it's also less than 1. So what are all the numbers that are greater than -1 and less than +1? It's all of these in here. Okay, anything that lies in between here. You could put a 0 there if you wanted to, because that's in between. But that's not the only number. Okay, there's fractions in there, decimals, all kinds of stuff. All right, there's an infinite number of solutions for this. But that's what this means. It means it's between -1 and +1. So how could we write this? We could write it like this. There's like 3 different ways we could write this. I'll tell you what, let's change colors. Make it stand out a little bit. So here's 3 different ways we could write our answer. So x is between -1 and positive 1. That's kind of how we used to always do it, all right? But you could also write it like this in that formal set notation. We talked about that yesterday. Oops, can't do that so soon. Right, there we go. It's basically the same thing as this, except you just add some brackets and you put that X and you put this bar. Remember what this bar means? It means such that. It's just a vertical bar. So it's all the real numbers that are X such that X is between -1 and +1. All right, that's basically what that says. You could also write it in that interval notation, and you could write -1, comma, +1. Since it's not or equal, they're both going to be parentheses. So either one of those three, you don't have to have them all three. Okay, either one of those, you could write it just like that. So that's what we did. We separated it. Okay, we took this right here, right? We made it into that. And then we took this and made it into this. And then we solved them both. We figured out how they go together. All right, graphing it really helps. Graphing can be very, very helpful here, especially when the X is on the right-hand side. We don't usually see it like that, but you could always just change it like this. X is greater than -1 is the same thing as -1 is less than X. All right, if you read it from right to left, X is greater than -1. It's a little bit easier to see. All right, and then you could graph it if you wanted to. I might even say to graph it. I think it does, tell you the truth. I think this problem does say to graph. So there it is. There's our graph. And you know what? I think on yesterday's lesson, it said to graph as well, and I forgot about that. So if you did your homework last night, and you're thinking, Mr. Hamrick, it says to graph, and you never said anything about it. You're right. I have it in my notes. I'm looking at it right there, and I completely forgot. But it's not that hard to graph. You could probably do that pretty quick. All right, let's do a second way. Remember I said I was going to show you 2 ways to do this? Let's do this a second way. Let's change colors. All right, so let's write the problem again. It says to solve. It's the same exact problem. We're going to get the same exact answer, but we're going to approach it maybe just a little bit differently. And this is probably the best way to approach a problem like this. It's a little more efficient, okay? So what I'm going to do is I want to get X by itself. You only have one X, but look, you got 2 inequalities. So you got 2 sides. You got this side over here on the left, you got this side over here on the right, and you got X in the middle. So what we want to do is get X by itself. So what would we do to get X by itself? Well, we'd add a 2. So I added 2 to this, but I have to add a 2. This is where it gets a little weird because you may have not done this before. But if you add a 2 here, you got to have to add a 2 to both the other sides. Okay, normally we just have a left side and a right side. But now we're going to add a 2 to this side of the inequality, and we're going to add a 2 to this side of the inequality. And you're allowed to do that. We had some properties that we talked about the other day that allows us to do that. So let's see what we get after we do that. So what do we get here? Well, that's a -3. We just added, so we don't have to change the sign of the inequality. That adds up to 0. We've got a 3x right there. And you got a less than, you got a 1 plus 2, and you got a 3. All right, that was pretty easy. All right, it's a little different because we haven't really had like an X in the middle. It's always been on the left or the right, but now it's in the middle. So now what we're going to do is we're going to get X by itself. Let's get rid of this 3 right here. So if we get rid of that 3, we divide this side by 3, and we divide the other 2 sides by 3. Usually, again, it's just a left and a right, but it's a little different this time. So that cancels out. What happens here? -3 over 3. Now, by the way, what did we do? We divided by a positive number, so we do not change the sign of the inequality. If you divided by a negative number, or if you multiplied by a negative number, you would have to change the sign of the inequality. We didn't do that here. We divided by a positive, so we're good keeping the inequalities the way they are. So this is going to be a -1. This is still less than. This is X, and this is a less than again, and that's a +1. That's our answer. Does that look familiar? Yeah, sure it does. Okay, that's what we got before. And you could write it those other 2 ways. I'm not going to because I just wanted to show you the method in order to get to this. But this was the same exact answer as we got right there. See that right there? See? That and that are the same answer. So I think this was a little more efficient. I think it was a little bit better than breaking them up into 2 separate problems and working them both and trying to combine it together. I think this was a little bit better, a little more straightforward. So you're probably saying, well, why'd you show me that other way the first time? um, just because I just wanted to see that separation between the two inequalities. So here we go. That's how you do that. Pretty easy. Let's do one more example and we will be finished. So let's go to this color. So this one, oh, by the way, almost forgot. Well, we already graphed it. Yeah, we graphed it right here, okay? They do say to graph it, so we need to make sure we graph it. All right. Let's flip this around. Example 10. Actually, there's two more examples. I'm sorry. I lied. Not on purpose. Example 10. Let's see what we got. We got -1 less than or equal. Oh, this is a little weird. 3 minus 5x over 2 less than or equal, and then a 9. All right. And what color do I want to pick? So what do we want to do? We want to get x by itself. So if you had this thing right here, what's the first thing you want to get rid of? You don't subtract a 3. Get rid of what's being multiplied or divided by it first. So this whole thing is being divided by 2, so we're going to get rid of that 2. How do we get rid of something that's being divided by 2? We multiply by 2. It's supposed to be a dot. Okay, so we multiply by 2. You could put it over 1 if you wanted to. It's fine. So what do we do to this side? We multiply this side by 2. And we come over here and we multiply this side by 2. We got to multiply everything by 2. All right, let's see what happens. Go back to the yellow. So what happens here? 2 times -1. Now, what did we do? We multiplied by a positive number. Does that mean we change the inequalities? No, we don't. Okay, because we multiplied by a positive number. So 2 times -1 is -2. Keep the inequality the way it was. This and this canceled out. So I've got a 3 minus 5x. And then, again, that stays the same. 9 times 2, that's 18. This now it looks like example 9, like the one we just finished doing. So let's go through it kind of quick. I'm not going to change colors on this one. So it's -3, -3, -3. Let's see what we get. We get a -5 for this. We subtracted. That does not change our inequality. Then right here, that's 15. Again, it does not change our inequality. So now we got one more step to do. We got to get rid of that -5. Now, do you see? We divide. This time we're dividing by a negative. So what do we do when we divide by a negative? You got to change the inequality. So we divide both sides by -5, everything by -5, the middle, the left, and the right. So let's figure out what it is. -5 divided by -5 is +1. But do we keep this less than or equal to? No, we don't. We divided by a negative, so this is the time when we change the direction of our inequality. We do it to both of them because you're dividing everything by a negative. When you divide by a negative, you change the sign of your inequality. All right, what happens here? We just have an x. What happens here? We get a -3. Now, this looks a little weird because the x is in the middle, but this goes to the right and this goes to the right. So what we're going to have to do is change things around a little bit. So I don't want to write it like this. I mean, technically, I guess you probably could, but we hardly ever write it like this with this as greater than. We want to make it less than. But if we make it less than, that means the smaller number is going to go on the left. The bigger number is going to go on the right because -3 is a smaller number. +1 is the bigger number. X is in the middle. How are we going to write this? Well, let's compare x to -3. Remember, x is greater than or equal to -3. So how would I write that from going right to left? I would write it like this. This and this mean the same exact thing. X is greater than -3, or -3 is less than or equal to x. What do we write here? Put a less than or equal to. Why? Because x is what? Less than or equal to 1. So we write it like this, from left to right. X is less than or equal to -1. This right here and this thing right here, I'm not going to circle it, but it basically say the same thing. But this is the way that we always write it. Okay, we almost always write when we have x in the middle, put the smaller number on the left and put the bigger number on the right and make these less than. This is the proper way to write your answer. Now, if you remember from the other example, did I do it on the other example? Let's see. No, I didn't. Yeah, I did. I did it up here. I wrote those three different ways to write the answer. So we're going to do that to this as well. All right, so let's do it. Whoops, where did that come from? Oh, sorry. So let's see. We could write it as, we could graph it. Let's graph it right now, okay? Sometimes graphing it first is pretty helpful. So we graph it, put a -3 right here, put a +1 over here. It's less than or equal to, that means it's going to be a bracket because it's closed on both ends, because there's or equal on both ends. And then that means x is going to be somewhere between -3 and +1. So x is going to lie somewhere in between here. You can pick any number that lies between here, and it's going to be the answer to our original inequality. Here's our original inequality right here. We're not going to plug it in. Okay, if we had time, maybe we would, but I want you to have time to work on this in class. So that's the graph right there. And part of the problem does say to graph, so make sure that you do that. All right, so that's the graph. We could write this in interval notation. Interval notation is pretty easy. It's -3, 1, and then a bracket here and a bracket here. This, and this basically mean the same thing. We could also write it real formal, okay, in that set notation. Do you remember that? So we could go like this, and we could go all the numbers x such that, remember that up and down means such that, and then you just rewrite all this. Seems a little extra, superfluous is the word I was going to use. Probably not the word you were thinking of. But anyway, it is a little extra. But again, if you go to college and you have to do stuff like this, it's nice to be able to say, oh yeah, I remember doing that in Mr. Hammer's class. You got to put that extra stuff on there. And sometimes your college professors are going to make you write it like this. And if you don't write it like this, you're going to get it wrong. All right. I am perfectly okay if you write your answer like this. Okay. But if you look in the book, you'll see this, I think, and then you'll see this probably as well. All right. They also asked you to graph it. That's part of your answer. So one of these answers that are circled, one of them, pick one of them, and then you also have the graph. So both of these are part of your answer. Let's do one more and we'll quit. Why do I keep doing that? Just making that noise. All right, let's change colors. Just go to blue. Now this looks a little weird. This is example 11, by the way. Example 11. It's supposed to be an E. It's a weird looking E. So solve. Check this out. Remember we talked about that reciprocal property yesterday? And we said we'd eventually get to it? Well, this is where we get to it. I bet you're thrilled to death now that we finally get to it. What does this mean when you have something to a negative exponent? We did this in the review chapter, okay? There was a part in there where we did it. So for instance, if I had 3 to the negative first, what does that mean? That means I take the reciprocal of that. That's basically what it means, all right? You could look at it like this. You could say, all right, put it 1 over 3 to the first. So what this means is you take it, you put it down the bottom, and you change the sign of the exponent. So that's basically what that means. And what's 1 over 3 to the first is just 1/3. Basically, it just means it's the reciprocal. When you take a number to a negative exponent, you're taking the reciprocal of it. That's what this thing means right there. Right? So how would I rewrite this then? If 3 to the negative first, or let's just say x to the negative first is the same as 1 over x. Well, what's this going to be? Well, it's all this stuff to the negative first, so that means it's going to be this, 1 over 4x minus 1. And you're probably thinking, ugh, that looked a lot better up here than it did here. Now you got this fraction. Well, believe me, with inequalities, this fraction is going to be nice, especially if you have this greater than equal to 0. Do you remember the thing we did? What was the letter we used? Did we use x? We might have used a or something like that. I can't remember. We'll just use x. Remember we had this? This was a day or two ago. We talked about this. And we said that if, let me see how I can use that with this. We said that x has to be a positive number, okay? You know, that's not the one that we talked about. We talked about if, oh, I forget what it was. Something about the reciprocal. So sorry, it wasn't this one. It was a different one. It was the reciprocal thing. I forget it off the top of my head. It said something like if a is greater than 0, then 1 over a is greater than 0. Do you remember that? So, and it said it the other way around too. It says if 1 over a, so if 1 over a is greater than 0, then, and this is where we're going to use this, a is greater than 0. This right here is what we're going to use on this problem. So if this is greater than 0, then what could we say? We could say that just the 4x minus 1 is greater than 0. So this is kind of weird, but it's taken from this thing right here. So if 1 over this is positive or greater than 0, then 4x minus 1 has to be greater than 0 or positive. So I can write this now as just 4x minus 1 is greater than 0. Man, that makes things look a lot nicer. I don't have to worry about that reciprocal and trying to solve for x because it's an inequality. If this was equal to 0, you wouldn't be able to do what we're doing right now. But since it's an inequality, if 1 over something is greater than 0, then that something, that thing that's on the denominator, is also greater than 0. It's taken from this right there. Okay, so we actually use this. And now I can go ahead and solve for x, and it's a piece of cake. So add 1 to both sides. That's 4x is greater than 1. We didn't have to change the sign because all we did was add, divide by a 4. We divided by a positive 4, so x is greater than 1/4. Divided by a positive, so we don't have to change the sign. So that's basically your answer. I would be perfectly content if you left your answer like this. The book does it that fancy way, x such that x is greater than 1/4. That's another way you could write it, or you could write it in interval notation. So x is greater than 1/4, so that means 1/4 is the smaller one, and then this goes all the way to infinity. It's not or equal to, so it's like this. So either one of those three answers would be correct if I wanted to graph it. X is greater than 1/4. You can just stick 1/4 right there, okay? Put a parentheses because it's not or equal to, and then it's everything to the right. Make a big fat arrow. Darken that in a little bit. There's your graph right there, because it does say to graph it as well. All right. So you could pick one of those three answers as your answer, and then there's your graph, and that's all there is to it. So that was kind of weird, all right? But this thing right here, I'm glad I remembered that. This thing right here is super important because that allows you to take it from here to there, all right? It's a little weird, but, oops, there we go. All right, let's write down some homework. And let's see. I always like to write it in red. I don't know why I always do that, but let's do it. So your homework is section 1-5 part 3. And it's page 133. And you're doing 69 to 87 odds. There it is, right there. That's your homework. All right, well, enjoy it. Have a good weekend. Have a good week, really, because you guys are all off. But you're supposed to be working on those senior projects, so don't just sit around and do nothing next week. Make sure you're working on those senior projects, and make sure you get your homework done, too. Get it done tonight so you don't have to worry about it this week. All right, so get this done tonight. In fact, this was a rather short lesson in comparison to what we usually do. So try to get this done in class right now. So when this video ends, flip your book open, start working on it, and try to get this done. It shouldn't take you that long to do this stuff. All right, you guys have a good one. We'll see you on Monday.